So now we're going to be talking about calculating resistance, current, and potential difference by using the definition of resistance. And to understand the definition of resistance, we have to know what each letter means, or what each definition is. So we have, we have V, or delta V, which is our potential difference. And that is calculated in volts. We have I, which is going to be our current, and that's in amps, or amperes, but we're going to do amps. I'm going to call them amps, and it's going to be A, and this one's going to be V. And then we have resistance, which is R, and that's going to be in ohms, and the symbol for ohms is that Greek letter. And then we have delta Q, which is our charge, and that's in coulombs, which is a big C. And then we have our time, which is delta T, and that's going to be measured in seconds. So these are usually what we have to use when we're solving for any of these, and now you're going to understand why. First off, we have the equation for current, and current is going to be I equals delta Q, which is our charge, over delta T, which is our time. So this is how you can solve for current. But we also have, the equation R, which is resistance, equals delta V, which is our potential difference, over I, which is our current. And then we have the equation for the potential difference, which is B, equals R, which is the resistance, times I, which is the current. So we can also figure out that by definition, instead of using this equation for current, we can do current equals V, delta V, over R. So we'll make it a lot easier so that we can see how each equation relates to each other. So we have current, which is the potential difference over resistance. We have resistance, which is the potential difference over the current. And we have potential difference, which equals the resistance times the current. So now we're going to do some problem examples so that you can see how each of them relate to each other. And first of all, we're going to start off with some easy questions, such as, let's see, how much current would a 10.2 ohm resistor, wait, I'm going to write the equations up here. So it's I equals delta V over R equals delta V over I, and delta V equals R times I. Okay, so now we're going to read the equation, the problem, and it says, how much current would a 10.2 ohm toaster oven draw when connected to a 120 volt outlet? So we're going to be using this equation up here, and it's going to be I equals delta V, which is 120 volts, over 10.2 ohms. And if we calculate that, it's going to be our current through this toaster is going to be 11.76, and that's going to be measured in amps. So that's how you would use the equation for current to find the current through an object or a resistor or through any kitchen appliances. So now we're going to do another example problem, and this one asks an ammeter registers 2.5 amps of current in a wire that is connected to a 9.0 volt battery. What is the wire's resistance? So we have resistance equals 9.0 volts over 2.5 amps of current, and that is going to give us 3.6 ohms. So that's going to equal our resistance, and that's a sample problem of how you would use the problem for resistance, the equation for resistance, to solve for resistance. And now we're going to do one last example, and this one's going to be a little more complicated, and it says calculate the current in a 75 ohm resistor when a potential difference of 115 volts is placed across it. So it's actually not that bad. So it's I, which is our current, equals 115 volts over 75 ohms, and that's going to give us 1.53 amps going through this resistor. And it says, what will the current be if the resistor is placed with a 47 ohm resistor? So that means that we're going to be replacing the 75. So instead of 75, it's going to be 47. So we're going to do 115 volts over 47 ohms, and that is going to equal 2.45 amps going through a 47 ohm resistor. And that is how you apply the formulas for potential difference, which is that, resistance and current, to solve for solve problems using those equations.